Awesome. So I guess we're all here because I'm suspecting we're all Python users and have had our pleasures with Python and thought, like, hey, this language is pretty fun and great. And then all of a sudden, it stabs us in the back, and things begin to break, and our packages that once worked start beginning to fail. And we will go through how these things happen and how we can prevent them. So some of the difficulties I've ran into with Python, getting started with Python, is there's multiple versions of Python I need to support. There's isolations between applications and projects, and then we have project package and dependency management. All things that have caused my system to blow up at some point in time. But before we get into like how Python has failed me, let's start from the beginning. Python was great to begin with. It's very quick to learn. I mean, we're even teaching it to elementary school kids these days. It has a very vast ecosystem to allow us to get up and running. And if you have not seen this XKCD comic, they even play to that point, saying, if the comic's just saying, like, you have your little Pythonista floating away and you have the developer on the ground, how are you doing that? And the TLDR, he's like, oh, I imported anti-gravity, or it was all the stuff in the medicine cabinet, one of the two, but you know, it was probably Python. And today you can actually in C Python do import anti-gravity. Spoiler alert, it just takes you to this URL. And even on python.org, it says that it lets you work quickly and integrate systems more effectively. And I kind of agree. I've gotten to leverage it to do a lot of interesting things to make my life a lot easier. For instance, once upon a time I was working at Verizon on the EdgeCast CDN, and there we were leveraging Python to build and manage our private cloud on top of OpenStack. OpenStack is built, all the glue that makes OpenStack run is in Python. We are also controlling and provisioning our infrastructure with SaltStack. So Python was also letting me manipulate a global infrastructure. So I think that's pretty cool with Python. Today, I'm at Disney using Python for compliance enforcement between AWS's Boto 3 and Capital One's Cloud Custodian, where Python lets me easily query my entire infrastructure and then make changes accordingly and alert on things that like don't appear to be the way they should. So even this presentation is created with Python. Oh, and I forgot to do something and reset the slides. Give me 1 second. But yes, this talk is demo heavy, so brace yourselves. Sorry, just going through my bash history to restart my Python environment. You know what? So it's a little less boring. You can see how the sausage is made. This is inside of Jupyter Notebooks, running Reveal.js. So I have a whole house of cards going on here. All right, I think, let's try this again. Let me try one more time because now my fonts are all off. All right, Again, even this presentation is created with Python. And I'm not connected. All right, there we go. Even this presentation is created with Python. And I did just execute that code. I can run it again, and, well, it just blinks. But we'll see. Again, this is demo heavy. This all worked an hour ago, so let's hope it still works. But Python, right. So Python is also fun. Just for the lulz, look how fast I can make a meme inside of Python. TLDR of this script, of this code, I have some obfuscated text, I decode it, I load an image, and I slap the text onto the image. Bam, we have a meme. So I execute the code, and let's display the image. Python is great until it isn't. So what happens with Python? Well, using Python sometimes is not the most fun experience. Here in yet another XKCD comic about Python, it's displaying how all the different ways we have to manage Python, if we're using Homebrew, Anaconda, we have different versions of pip going on, and then but at the bottom of the comic it says, my Python environment has become so degraded, my laptop has been declared a Superfund site. So yes, Python can get unwieldy pretty fast. And then things begin to break. Whether it's inconsistencies in prod, you try to share code with your teammates and their laptops are inconsistent from yours. Sometimes Python apps that were once running all of a sudden stop running on your laptop and throwing exceptions. There's dependency issues, and then your system Python's all borked. And then we are a sad Pythonista. But these problems are not unique. Ruby and JavaScript have had these same problems, but they have solutions if you're familiar with tools like bundler and npm. Python has a solution. We can bang on prod till it just works, but maybe that's not the best idea. But Python does have some real solutions, maybe too many solutions, and then especially when you're coming into the language, and even as someone that's been doing the language for a while, it's like, which tool do I pick and why do so many exist? Well, that's what we're going to talk about today, and I'm here to help with a workflow and solution that will make life so much easier and make Python great and fun again. So it can be great again. We will be talking about PyEnv, pipenv, and pipx, and we will be demoing all these tools. But first, what's not so great? I'll be starting with pipenv, and why do we even need pipenv to begin with? There are so many versions of Python that need to be supported. Right now, the 3 versions that are actively being maintained are 3.5 through 3.8, which all have their different sets of features. So if I'm running a library that uses data classes and I have 3.6 on my machine, it's not going to run. And for those of you who thought we were done with Python 2, think again. There's a lot of quote-unquote enterprise-grade software out there that is yet to be converted over. Even some projects like Calibra are still in the middle of transitioning their code base to Python 3. So you may be in a situation where you have a very real need to still support EOL versions of Python. And then there's System Python. While technically not a version per se, but it is another copy of the interpreter we need to be cognitive of. System Python belongs to the system. We shouldn't be mucking with it. We have less control over it. I mean, if you go, sudo pip install, you're going to have a bad time and break your System Python. And I've definitely learned that the hard way. But things can be better, and that's where PyEnv comes into play. So it helps us manage versions of Python. It can install not only different versions of Python, but different builds of Python, because I support both CPython and PyPy, and I can have them all living side by side very happily. And PyEnv lets me switch between the interpreters very easily. So let's get into a demo and see how it works. So installing any version. Let's take a quick look at what's available. So I've just grepped out the latest versions of Python 3 available, and you can even see like any point release, release candidates, and even development branches are all available for us to install if that's what we need. Awesome. So let's install Python. I'm just kidding. We're not going to sit here and watch me install Python. But I have pre-staged a few versions of Python. On my environment, I got our system Python 2.7, 3.7, 3.9, and even a copy of PyPy. Awesome. So which Python's actually going to run when I do type Python 3 -- version? Well, right now it says 3.9. Why is that? So Pym version gives me back how I prioritized my Python interpreters. And you can even see where it's set by, and there's a .version file living within my home directory that pym references. So cool. So the other versions of Python, if I do 3.7, hey, it works. And I have Python 2 installed, correct? It is installed, but it was not active. And Pym lets me know that, like, this version you're trying to run, it's here, I found it, but you told me not to use it. So Pym lets me temporarily switch if I need to. So Pym shell lets me reorder my priority of my Python interpreters for the bash session. So I do Pym shell. In this case, I'm going to throw 2.7 at the beginning, and I'm going to prioritize 3.7 over a more stable version over our dev version of 3.9. And I go ahead and execute that. And you see that 2.7 is now at the top in the exact same order listed. PyPy is no longer selected. So let's verify that it actually does what I say it's doing. And when I execute Python 2, I get 2.7 back with no errors, and Python 3 now gives me 3.7. Great. If I need something that will persist over bash sessions, I can set versions I can set overrides per path. So that's where Pym local comes into play. Here it's like I want my default to be 3.7. I need Python 2.7 available, and just in case, let's throw 3.9 at the end. And I do that, and now 3.7 is my default. Wonderful. Just to prove the point, 3.7 is first my default in the same directory. I cd to root, and we're back to our previous global default of 3.9. Yay, it works. Magic. Not really. It's just dropping a file .python - version. Some of you from the Ruby world may recognize this from that Ruby has something similar with the Ruby - version. So these patterns are not unique, and so it makes my life a lot easier, so I can just cd and start running with the right version of the Python I need for the scripts in that directory. So, and I can clean up after myself with just pym local -- unset. And now that's unset, when I run local, it throws me an error saying it's not configured, which is to be expected. Wonderful. Python's getting better. I don't need to worry about having all these different interpreters on my box and how to manage them. Now I can use any version of Python. I'm not stuck. I can install any package. I can update my packages even if they want to change to the latest version of Python. I can still be happy. I can test against multiple versions, and I can switch in between interpreters, and I can create virtual environments with any version. And we'll be talking more about virtual environments later. So, but there's more that's not so great. We have 2 more tools to cover, but first, why do we need these other tools as well? Because there's dependency conflicts. And if you've ever, like I said earlier, if you just ever pip install right into your system, you're overwriting your repos, packages, and things are going to get out of sync, and it's not fun. For example, this is what happened to me with SaltStack before. I had one library using, I had one application that needed access to GPG. And it's like, great, we have our installed, we have Python - GnuPG, so we can talk to GPG. Wonderful. I load it, and I see the module name is GNU-GPG, and it's the exact same version. Nothing surprising, exactly what we expect. Then I'm working along. I'm like, I need another tool to do my job, and I go ahead and install it. And it also needs GNU-PG. But it decides it needs a different library. But yet, both libraries import as GNU-PG. As you see here, now we have two different libraries, two different versions installed. So when I go to import GNU-PG, which one's going to load? Does anyone want to take a guess?
Depend on the version and the first thing. So it's probably, let's choose the lowest one.
So we got possibly the lowest one of a version-wise.
I think it depends on the file. But I think it's the regular GNU-PG.
In this order. So, because I've been playing with this, it is deterministic, but I wasn't 100% sure it's based on the higher version or alphabetical, but it's probably path actually, as I'm thinking about it. But, so, yes, the new one does load now. That's just some code to force it to Python to reload the module. And we've reloaded, and we're now at a completely different library. That means all the existing packages that were installed that were using the previous library are now going to explode because they don't have the same APIs. Wonderful. And just out of curiosity, what if my system Python was using GPG? And oh, guess what? There's yet another library for GPG. I'm guessing this doesn't import as GNU-PG, but still, I think you get the idea that like this could set up for a bad time. You know, here, if I installed it in my system would be borked, everything is broken, game over, format the box, redeploy your distro, and try again. Great. So, yeah, the world's over. Go home for the day. You can try again tomorrow. Python does have a solution. They give us virtual environments. Virtual environments provide us isolation between our projects. We get a copy of an interpreter and our own set of dependencies. So, great. As long as the packages we're using don't do what I just did there, everything should be happy, right? Well, have you tried using virtual environments? I don't enjoy the experience. This is a standard workflow for using in a virtual environment. Top line, we're setting our version of Python that we're using. Then I import the virtual environment module and create my virtual environment. Then I activate the environment. Then I do some stuff in that environment. Here, I'm just going to display which Python 3 executable we're using, and then I'll print do a pip list to show the environment. And then we deactivate, and then we get to do this whole song and dance again for the next tool or project we want to work on. Oh, well, sorry, let's actually execute it. Personally, I don't find this enjoyable. And now we have to create an environment for everything that we're working on, whether we want to run a tool, whether we want to work on a project. So that means we now get to manage virtual environments. And I don't want to. That sounds like too much work. I didn't start learning Python to do more work. So there is a better way. Today we have tools like pipx and pipenv. Pipx will deal with the virtual environments when we're wanting to install or run applications, and pipenv will help manage our virtual environments if we're developing it on projects or libraries. So more demos. Let's see how pipx works. Again, for running and installing our applications and keeping them nice and isolated. So let's install a thing. I'm going to pipx install pyjokes, because sometimes I need a little pick-me-up. And just like pip install, pipx install brings in my package, and the output tells me what version. We got 0.6. The version of Python, our default is 3.9, and it even put 2 executables in our path for me. So that means now that pyenv is installed, pyjokes is installed, I just execute PyJokes. Hey, it works, and it returns a number of days since I have encountered an off by 1 error. 0. We can do better. Software developers like to solve problems. If there's no problem handily available, they will create their own. Sounds about right. So where did it actually go? So if I do pip xlist, and if you've seen the pattern, very similar to the pip CLI interface, it lets me know right off the top where the virtual environments are living. There's a path underneath my home directory by default. Where the apps are getting exposed to, it puts a .local bin in my home directory that is part of my path. And then we see that PyJokes is there second underneath pipenv. We'll be talking about pipenv shortly. So wonderful. It's all nice and isolated. And we can easily get rid of it. Much to probably no one's surprise, we do pipx uninstall PyJokes. And now it's gone. Wonderful. Though, what if it wasn't ready to run with 3.9? Well, pipx also lets me define what version of Python interpreter I want. So with -- Python appended at the end of install, I can do -- Python install Python 3.7. Let's give it an actual supported version of Python. And it goes ahead, reinstalled, and now it even says, like, now I've installed with 3.7. Awesome. So I can now leverage the I can leverage PyEnv with pipx so I can support whatever application I need to install. But it can do even more than that, because what if there's just a tool I want to run one off, or just I'm just testing. I don't necessarily want to install it and have to uninstall. We're doing more work again. I don't like to work. So I can get a temporary sandbox. I can just do I can do a pip run and get a temporary virtual environment. It will build a virtual environment and clean up after itself for me without me ever having to think about virtual environments. And so let's run a Python implementation of calce. And I do pip run calce, and I pipe in fortune, and he who laughs last is probably your boss, I suppose. So did it install? We do pipx list, and we only have our PyJokes and pipenv listed. So awesome, Python is better. I can run tooling without managing my virtual environments. I'm a lot happier. I have all my tools nice and isolated rather than pip installing -user all the things and watching them crash. So we still got to deal with development environments, right? So sometimes I need to write my own libraries. So pipenv provides a workflow that will manage our virtual environments for us. So let's just take a look at that. We will start by writing a script. So calce is cool, but we're at scale, right? Let's try tuxce. So very simple script. I'm doing a lot of cheating. Calce actually provides me tux. So I just swap out all it's doing here, I'm importing calce, and then I'm reading from standard in, and I'm telling it to execute the library calce with tux and passing the phrase from standard into it. So awesome. Let me actually write the script, because this is all live. And OK, but I need my virtual environment with my dependency calce. So pipenv to the rescue. I do pipenv install calce, and it will load up a virtual environment with my dependency. And you can see here, we've created a virtual environment. It's adding calce. Well, that's not where I'm installing calce. It is mentioning this pip file, and we will touch on that in just a second. But we built a virtual environment. It says it installed our dependency. Wonderful. Can we run our script? So pipenv run will automatically run inside the virtual environment for us, and then I'm executing Python 3 and my script as I would normally. And hey, it looks like it works. So real quick, what is this pip file about? it, it, it can replace requirements.txt. So if you notice here in my packages, I have my dependency now, and I can even tell it what, if I don't want to use PyPy, say I have my internal Python repo inside my enterprise, or I can easily point to it there. I can actually have a list of several repositories here if I needed to. So, wonderful. So let's move on to creating an actual application. So let's turn that tuxay into an actual full-on application. So we need our standard setup.py. I've actually moved our dependency into setup.py because this is where we should be putting our abstract dependencies. And I've also created an entry point so it can actually install a CLI tool. So cool. I'll write my file, and I will update my environment. Rather than just editing the pip file in front of everybody, I will just blow it away and let pipenv rewrite it for me real quick. And I do a pipenv install editable, and I just point at my local directory to install the local files. Rebuilt it and added tuxay to the pip file. So did it actually work? If I do pipenv run my CLI tool, and it looks like it works. And I have passed in pipenv -ve and v, and which will return the location of our virtual environment. So wonderful. Looks like it's working, and I haven't actually had to deal with the virtual environments directly myself. But what if I need some development tools? I am a big fan of Pylint. You should be always, if you're not using Pylint, Flake 8, something, please lint your code. So with pipenv --dev, I can note that this is a dev tool, but when I go to rebuild my dev environment, I can get exactly all the dev tools I need. I should have really put some sort of version bound there, and I guess I got lazy, but yeah, you should be bounding versions that you're installing. So what does the new pip file look like? So under dev, we have our development environment, development tools. So if you want to install other things like isort or anything else you might be using on your code. And then under packages, normally I only have the tool that the code that I'm developing listed here with this editable install and path dot. And then I put all my other development tools under dev. That's how I use it, because all my requirements for the application itself should be in setup.py. That way when somebody else goes and installs it, they don't need to understand pipenv. The other developers on my team don't even need to worry about this. To me, this is an easy tool to adopt, because it doesn't force other developers to change their workflows either. But that does mean you need to be exporting your requirements.txt file, because if that's still what they're using. Eventually, this should be replaced, and I'll show you another feature of why the pip file is superior in just a second. But first, we can clean up after ourselves, and with --rm, I have destroyed my virtual environment. And we can rebuild and even specify whatever version of Python we want. So very similar to pipex, I can just add --python, and if I don't want to install the latest because production is using 3.7, so let's just develop in what we're deploying on, I can easily do that too. And you see that we are now using 3.7 instead of the environment's default of 3.9. And everything is rebuilt. Even somewhere in here it should be listed. Oh, I guess maybe there's not enough help. I was going to see if there's it's telling us that Pylint's installed. We'll see it in a second. It does throw warnings because the pip file does specify that we are installing that the environment is supposed to be built with 3.9, and I overrode it. But for the sake of the demo, I just blew past that. But yeah, we can specify the version of Python we want as in our pip file as well, so that way we get, again, consistent environments. So pipenv also helps with our dependency resolution. And this is where I think the pip file is superior to pipex. But people normally use the requirements.txt file with pip. So let's take a quick look at our dependency graph. And you can see tuxay at the bottom is very simple. It just has calsay as our dependency. But over time, our dependencies can get more complicated. If you take a look at Pylint, it has a dependency of asteroid, which uses 6, and a variety of other libraries, which all have different bounds of version requirements. And making sure all these dependencies play together nicely can get unwieldy. Just for a more complex example, we can take a look at what my presentation is running in. And you can see right here I'm using Rise, which requires Jupyter Notebooks, which requires IPyKernel, which requires IPython, and things scroll away and get out of control really fast. And some of you who may have worked with projects with these kind of dependencies may be very familiar with dependency hell. So pipenv helps us get out of that kind of afternoon, or even days trying to sort that out. So how does it do that? It can generate a pip lock file for us. For the presentation, I had overridden it with an environment variable because it takes more time for it to sort all these things out. And you can see I had used pipenv skip lock equal to true. But let's do it once just to show you what happens. I'm going to forcibly tell pipenv to lock. So even though I have it set, I'm telling it, no, please write my lock file for me. And you see here, it's building our lock file. And we will take a look at it in just a second. One more second. Any second. So it does take a little time. This is why I had disabled it for the presentation, so I wouldn't have to hit this every time. Great. Our pip lock file is written. And this is where concrete dependencies go. So in our setup.py, I had a bounded version of my dependency calsay. Here in our pip lock file with the concrete dependencies, I just grabbed a piece of it with a JQ. We can see my dependency calsay, and it's pinned to a very specific version of calsay 2.0.3, and even has the hashes there so that when I pull from PyPy, I can confirm it is the exact same blob I'm getting from PyPy. So this is why I think this is superior to using the traditional requirements.txt. I don't have to manually go in there and try to figure out and pin every dependency myself. And it will do the hash checking for me. So if I have somebody trying to do some sort of man in the middle and drop me some sort of payload, this will catch it. So even this presentation's environment was created with pipenv. And there's my pip file. You see I had pre-staged my GNU libraries for the demo. I had Pillow for when we made the meme, and there's Rise. So I like pipenv because I can also create arbitrary virtual environments for doing things like this. Because I didn't create a package or even a script here, but I still needed a virtual environment. But now I don't have to manage it myself. So this is like swell, and some of you be like, okay, that was a lot. Why do I care about all this? Because what we just did here is virtual environments are an implementation detail. I don't have to care about them too much anymore. I can still get in the weeds if I want to. So Git talks about having porcelain and plumbing commands. So to me, having pipenv and pipx are my porcelain commands, where pip and virtual environment are my, did I say that right? Pipenv and pipx are my porcelain commands, and pip and virtual environment are my plumbing commands. So I can get into the weeds if I want to, but I don't have to anymore. So TLDR, I can now manage multiple versions of Python. I can keep all my tools isolated, and I can keep my development environments isolated. So without ever having to think about virtual environments again. What do you think, Tux? I use pipx run to my application we just made, and hey, Tux says Python is great again. This solution uses the Python Packaging Authority's recommended tooling. It works with core Python libraries and tools. And even at this upcoming PyCon, there's a workshop teaching these tools and more tools, but does teach these tools. So I think I'm on the right track with this set of tools and workflow. Again, yeah, like I said, PyEnv for the version management, and abstracted away pip and virtual environment with pipex and pipenv. So Python is great again. We can let our children play with all the Pythons. And yeah, these slides are already available. I probably need to get push what I just did right now. But the last version is up right now on GitHub. Yeah, is there any questions? Yes, sir. Oh, thank you.
Any easy way to install pipex without brew? I'm not allowed to use brew.
So what I do with pipex, so there's two ways. There's what I'm doing right now is I just do pip install -- user pipex, and that's the only tool that goes into like my area. And then it doesn't have to go into every version of Python. It just has to go into whatever your default is that you're using. But there is another library out, and previously pipex used to install this way. It used to build itself a virtual environment, put itself in there, and that way it would install as one of the tools, like how you saw PyJoke, and it would install like that. There is I believe a repo called pipex in pipex, which has a setup.py that does that magic for you. I haven't used it, but I do want to start using it because that just seems more logical to me. So yeah, you don't need brew. Yes, sir.
So at the beginning you installed a couple different versions of Python. Where did they come from?
Oh, so the question is, where did the different versions of Python come from at the beginning? So I'm pretty sure, I need to verify, but I'm pretty sure the C Python came from wherever python.org publishes the tarballs, and the same thing with where PyPy publishes them. I'm pretty sure that's where they're linked to. I need to go check and verify that though. Of course, PyEnv is a very nice. All it is Bash. So, and of course it's on GitHub. So it's all there, and I'm like pretty confident it's just pulling from the source of the Python of the builds for those Pythons. Not out of version control, but you know where they publish their like their tarballs. Oh, actually, PyEnv can also fetch you because it will compile any of these builds you want as well, and it can either fetch source and compile for you, or it can if it can find a pre-built binary that matches your system, it will just pull that down too, so you don't have to compile the whole world as well. Anything else? Yes, sir.
If you have several versions of Python installed on your system, like just from your regular package manager, and pipenv would want to pick up all of those and use those, or just have to install them from whatever system you are?
So the question is, how does pipenv play with the system's multiple versions of Python from the system? So I'm honestly not 100% sure. I know I've been in this situation before during the whole Python 2, Python 3 crossover where my distro was installing two versions, but I don't generally point at my system versions. I only point at my installed versions, so I'm not 100%. But I would expect if I told my default version to be my system Python, it would use Python with no number after it as Python 2, and then Python 3 to be whatever the system's Python is, if I told PyEnv to use the system as default. That would be the expected behavior, but I generally never list my system Python in my set of available Python interpreters. So, not 100%, sorry. Yes, sir.
I have two questions. First one is, are you using this in conjunction with like an IDE like PyCharm that has some of these features, or are you using this more with a regular Sublime type text editor?
So my two editors of choice are, I'm going to say something opinionated, Vim, and I do like PyCharm for my IDE, and PyCharm works with pip env. So whatever I've whatever I've told my pip file to build with, PyCharm will go ahead and pick up whatever it needs to pick up, and it will figure out what Python if I've defined the Python interpreter, it will go and figure it out and will work 100% with my with PyCharm. It also has VS Code support as well. But when I use Vim, I am doing things a little more manually, so I've already have it all ready to go when I'm launching Vim.
So my second question is, I've been kind of wondering if containers could be leveraged to kind of deal with this kind of general problem. Has anyone
you want to have a packaging talk? We can do that too. Yes. So there's different. So are you asking if to just ship the entire thing inside of a container? You have your interpreter, you have your dependencies, and who cares about virtual environments? You got your container. So I like shipping my software like that, but I don't necessarily do that for my my development environment, because then tying my IDE inside the container and doing all these extra hoops, I don't like working like that per se, but I do like shipping my software that way. But that's a whole nother rabbit hole of how to package software and how we can ship it as a VM too, or we can so yeah, I ship personally my projects. I put my Docker file, my Docker Compose, and make my nice little blob that gets on the Docker Hub. And then I also have my installable package so it can be leveraged as a dependency on PyPI. So I ship it all like that, and then it's up to the user, whatever fits their use case the best. Yeah. Yes, sir?
Pip is about a little over 3 years old now. It still seems that requirements.txt and pip is still the norm. What's stopping pip from more widespread adoption?
So the question is, what's pip env being several years old? Why hasn't it been more widely adopted where requirements.txt is still the standard? So I don't know. Maybe I probably live in a bubble. To me, it's gotten wide adoption, especially after the Python Packaging Authority endorsed it, and it got more adoption. There has been some community back and forth on how to move forward. There's been pushback on PyEnv for so let's air some dirty laundry. So PyEnv did have some bumps when it was first getting off the ground. They were developing really fast and changing the UI out from under people, and that wasn't creating a great user experience. That has stabilized, but now things have gone to the other direction where the maintainers are trying to pay off technical debt, and they've been really slow to have a release, and that's made people uncomfortable. On top of which, new standards are coming out, and so now we have there's a competing tool. So there are more slides for these questions. So there's a competing tool that often gets compared, people are just use Poetry, but it's not solving the same problem, but it seems to get in the same conversations. And Poetry does not work with standard tooling, because if you don't have your setup.py, you can't do an editable install with pip, and so there's all these the Python, and this is what we need to make Python great again, because it suffered from there's all these different competing ways to do things, and then they don't always have the greatest interoperability. So I actually really like Poetry, but it's not solving the same problem. no editable install. Oh, I even demo it, but these are the reasons that I'm stopping from it, because like I couldn't write this project in Poetry because I would need it just an arbitrary virtual environment. Poetry is really to package your Python application, so I'm not trying to do all that scaffolding and setup. If I'm doing all that work, let's just go back to using virtual environments the way they were. And it's still lacking a couple features, but it's gaining adoption. So people are now putting effort here instead of pipenv, even though they're two different things. But I do continue to think pip, like, to me, I like that workflow a lot. That's why I say pipenv is a solution. It's gained adoption. If the Python community, the whole thing about the Poetry not working without setup.py is not a fault of Poetry or pip. That's actually, there's no actual standard on how to let that, for that use case, for that situation, even though Poetry uses this new standard where you have pyproject.toml instead of all those files. But it's like, well, what about all the tooling that's still expecting setup.py, and like, because that's more of a setup tools feature. So what is pip supposed to do in this situation now? So Python continues to evolve and hits, it's like, oh, we have new features and a new bug. Like, so I guess I danced around your question a little bit. Like, I didn't answer exactly what's slowing it down, but the Python community, as you saw, we have, in my earlier slide, we have 1 million solutions. Those are the kind of things that are slowing things down, because we're not coming together as a community to be like, this is the way we do things. This is our bundler. This is our NPM. This is how we're doing it. And so that's probably the biggest reasons that are holding up a standard and adoption. Any more questions? Comments, criticisms? I was really happy with this slide. Oh, yes, sir.
What are your thoughts on using Docker? I know it solves a different problem, but instead of using like a pipenv, just using different, containers to run different versions of Python.
So having different containers for different versions. I did that early on, and it was difficult. I mean, if you have in your container your Vim and everything you want, or you're like just, I guess you'd be probably mounting in your volume that you want. Yeah, that can work with Vim and things like that. But if you having that whole IDE experience, it can get a little unwieldy. It's doable. If that works for you, that is a solution. You can run your talks and everything you need to do your testing, and it can work. I used to be 100% Vim, and then a coworker showed me what I can do with PyCharm, and I was just like, oh no, I need an IDE. So you could hook in remote editing into your container, but now I'm doing more work again. So if you haven't noticed, I didn't start programming to work. I'm lazy, right? So yeah, it's a workflow. If it works for you, wonderful. If you have your environment and your tooling and all working like that, it's definitely a viable option. But this is more of the common workflow and toolings where this pattern, I'm not my teammates don't have to use pipenv with this pattern. They don't have to use pyenv or anything. I mean, they can blow up their system however they want. But so that's what I also like about this. I'm not imposing a way of doing things. Like if I use Poetry, now everybody that's contributing to my project has to learn how to use Poetry. It's it's tied to it. So that's why I'm advocating this process.
More elegant solution.
Yeah, more simple, elegant. Sure, thank you. I'll tell you, it works for me. Not everybody wants to run Docker on their machine sometimes. But I love it, but not everybody does. Any other questions? Well, if not, I will let everybody. Oh, yes, sir.
I don't see the microphone, so I'll just speak up. I'm curious, do you have a methodology for moving? Because I share my code, so what I'll do is I'll develop locally with my own tools, and I want to put it into a container to ship it to another developer to use. Do you have a pipeline for moving that?
Oh, so inside the container, yes. So, like in my like CI/CD builds that are launching inside of a container, I have a pip file on my personal project 'cause I don't have the requirements.txt. And the way I leverage that, so that because I don't want it to build a virtual environment inside my container because that just seems like a waste. Pip does give a -- system and will install right into where the system is because like my container already is my virtual environment. So yeah, if that's is that what you're looking for, like a -- system, and that way like here's your container. But yes, I do have to bring in pipenv as into the container so I can actually execute on that. Any more questions? Well, if not, I don't think there's a talk after me, so unless you guys have other talks to go to, the expo floor is still open. So thank you all for coming.